Good morning, Mike Hughes here. Thought I'd share with you guys a couple of tricks and tips on the installation testing and troubleshooting that you might wind up doing with installed GPS tracking devices in some of your equipment. Probably easier to do this in a video than write all kinds of volumes of documents. So we're just going to go through a couple of quick things, ways to best test it, ways to ensure that the installation is going to do what you expect it to do. Before we get started with the techniques, let's talk about the devices that are in your vehicles and your equipment. Generally, you're installing these GB75 devices. These are GPS tracking devices. They're programmed to behave according to the signals that they get from the equipment. Power and ground obviously cause the device to operate. But one of the critical factors in how these devices behave is the white wire, the ignition wire. It is that wire that tells this device when the equipment is running and not running. And it's used for a whole bunch of different behaviors. Number one, it controls the counting of engine hours. Number two, it controls the power behavior of the device. If the ignition circuit isn't operating properly in relation to the equipment and the GPS device, then we can see false readings in engine hours. We can see exhausted batteries because the device never knows the equipment is off and should go to sleep. So it's very critical that not only does the device have power and ground, but it also has a very properly wired ignition circuit. That means that it goes on and off when the equipment goes on and off. As we've been talking about some of the things that you've encountered in the field, I've seen some videos and so forth about, and some pictures about how the tests have been conducted. And you're installing these devices with cables that we made for you, and I've got a prototype of it here. Those cables typically have a Deutsch connector or a Delphi connector, according to the type of equipment you're installing. They have fuses, and they come around and they terminate in an 8-pin Molex connector that connects to the GB75 or other device that you might be installing. The cable is important. It has fuses for both power and ignition. The ignition fuse is identified by a white sleeve on the fuse holder. That way you always know that you're dealing with the ignition side. The device will not get power or ignition signals if these fuses are missing or they're open circuit. So please be sure that the fuses are installed and that the fuses are good when they are installed. In some of the videos that I've seen, some of the measurements and testing has been done by probing into the back shell of the Deutsch connector or the Delphi connector. While you can get readings here, it's still possible for the readings and voltages that you measure on this connector to not make their way around to the device and therefore cause the operation to behave properly. So I'm going to show you some other methods for measuring the device instead of putting your voltmeter probe or your test light probe into these connectors. I'm going to suggest that you make those measurements at the 8-pin connector, so that way we know that the pins and the wiring and the fuses and fuse holders and everything else is all good until it gets to the device. So in the first step, at the end of installation or when you're performing troubleshooting, I'm going to suggest that you disconnect the GB75 from the circuit that you're working on, from the equipment, and test only the wiring that's involved in this at the 8-pin Molex connector. You'll see that there's a red, a black, and a white. The black is ground, obviously, the red is power, and the white is the signal for the ignition. You can measure this a couple of different ways. One of them is with your handy multimeter. Obviously, volts DC applies here. And what we want to be able to see in the multimeter, and hopefully it's visible in the video, is we want to be able to see, number one, that we have power, and number two, that the ignition voltage line behaves the way that it's supposed to. So we probe the ground and power. And we see that we have 13.9 volts on my benchtop power supply. We also, in my benchtop power supply, have the ignition switch simulated to be in the on position, so that we also read 13.9 volts when we measure the white wire. By disconnecting this little yellow jumper that I've got here for my test purposes, now I can go to the ignition pin and I can read 0 volts. That simulates me turning the ignition switch on the equipment off. It's very important that the voltage measured on the white wire with reference to ground be at a voltage of 2.0 or lower in order for the device to know that the equipment has been turned off. Another way to test these signals is with a typical test light. So I have my handy little test light here. I'm going to connect it to ground for my benchtop power supply. And I'm going to probe first into the power. So I insert my probe tip into the power and I measure 13.8 volts and my light comes on and so forth as it should. I've still got the yellow wire disconnected, simulating my ignition switch. I have no power on the ignition circuit, which is appropriate. When I connect the ignition wire, the simulated ignition wire, in your case turning the key on, and now I go to probe the white wire, I have 13.9 volts. So this is another way to indicate to you that the ignition switch is behaving in the way that the device will need it to behave in order to work properly. We've also provided a test device to you. More are on their way. Basically 2 LEDs in a little device that plugs in to this 8-pin connector in place of the GB75 or other test device. What it does is contain 2 LEDs, a red LED that indicates when power is present, the yellow LED that indicates when ignition voltage is present. By plugging that tester into this connector, the red LED should illuminate and the yellow LED should go on and off as you manipulate the ignition key on the equipment. I don't have one of those devices here. I sent you my only prototype. But we are making some more of them. I think it's a pretty simple thing to understand. You simply plug it in and look at the lights and understand the status of the equipment. Important stuff. I recommend it be tested at the time of installation, and I recommend that these procedures be used when we are troubleshooting devices that may not be behaving in the ways that we intend them. Thanks. I hope this is helpful for you. If we can tell you more about these installation techniques and so forth, please let us know, and we're happy to do so.